loan to that, which is 10,000. Remember, the loan is always the present value of all future what? Payments. So therefore, it's 10,000 times my payment times my present value interest factor annuity, right? Which is 1 minus 1 over, what is the interest rate again?
10%.
10%. So 110,
Yep.
because again, we're making one payment per year, right? Raised to the power
10.
10 over 0.10. And then you solve for payment. See that? That payment will be your constant total payment. Do you see the difference now between those two? Say yes or no?
Yes.
Yes.
Good. $16.
Many economists assume that we will have an inflation rate of approximately 2.5% over the next few years. If the price of cars is tied directly to inflation, what will a new Camry cost you in 5 years if the price today is $32,000?
So basically here I'm saying that the price will increase by the rate of inflation each year. So it's almost like a future value problem, right? Because the interest rate could be viewed as the rate of inflation.
So I thought it was that inflation rate problem that we weren't gonna be doing.
Yeah, but this is
it's not.
different.
Yeah,
This is simple enough,
okay.
right?
No, I didn't know that. I mean, I saw inflation, I said, oh,
Yeah.
this must be from an old semester.
No. I mean, that's still valid, because here what you have to understand in this case is that you could treat that rate of inflation as if it were what?
The growth rate.
Like a growth rate. The interest rate is a growth rate, right? For example, if the price is 1,000 today, and I tell you the inflation is 10%, what's the price next year? Well, it's going to be 1,000 times 110. That's exactly the same concept. Now, what is the inflation in 2 years? Well, it's 1,000 times 110 raised to the power?
3.
No, well, in 2 years.
3
Okay, 3 years. 3, 2, right? So it's exactly, it's pretty much the same thing. However, what I will not do is I will not ask you questions, that relate to real value, nominal value. That I will not do.
That's what you mean by inflation?
That's right.
Okay.
Yeah, because the connection between the difference between a real value and a nominal value is inflation. And I will not really ask for those questions. But this one is simple enough because it's still very close to the concept of present value versus what? Future value. So I promise there will be no question about real values versus nominal, because we need to understand inflation. So would you know how to do this one now? So it says here, what will a new Camry cost you in 5 years if the price today is 32,000? So therefore, it's as if we were doing a future value, which is the 32,000. Is that correct? Times what is the rate of inflation? 1.5 raised to the power 5, right? Is that good?
Yeah.
Next.
What is the present value of 25,000 to be received in 9 years if the interest rate is 8% compounded continuously?
Compounded what?
Continuously.
Continuously. That's really like that infinite compounding, right? So we know that we have to use some sort of exponential.
Yeah.
Right? So here, the future value is really the present value times e to the r minus t. Right? Where r is going to be the annual rate, and then t is number of years,
Sorry, what's the E again?
exponential.
Okay.
Do you see it on the calculator? It's usually.
E to the X?
Yeah.
Well, it could be, yeah, it could be that.
Yeah.
It's the e to the x, right?
Yeah.
Very good. And of course, this would be your x, right?
Yeah.
So now here, we're not really interested in the future value, we're interested in
Present value.
present value. So then, if we solve, then you get a PV is really the FV
Divided.
over e to the r times what?
T.
Uh-huh.
And now, and then we solve, so then the future value here is really 25,000, right?
Mm-hmm.
Over e to the r, what is r here? 9?
9.
Times, what is the, actually r is not 9, r is 8%.
8%, right.
And then what is the t? 9, right? Now your question now is, okay, how would I do this, right, on the calculator? Again, here we cannot really use any financial key. We simply have to use the financial function. Would you know how to do this? No? Yes? I think sometimes it's easier to simply say that, because this is also the same, it is the same as 25,000 times e to the negative, right?
Oh,
0.08
okay.
times what? No, it's the same thing.
Okay, that's
I
easier.
think if you know that, it might be easier.
Yes.
Then what you do is first you start with the x, right? So you do 0.08 times 9 equals, whatever you get, you change the sign, right? And then you call the exponential function,
Okay,
right?
I want to try.
Does that make sense?
Yes.
Yeah. So.
So do you get the answer?
12,168.81.
12,000
168.81.
right?
Sorry, I keep getting an error, so I'm not entering it right. If you could just say how to do it again
Okay. let me see.
with the E.
Okay, let me see, 0.08
Yep,
times
9.
9,
Yep,
and then you change the sign,
yep.
and then,
And then you do the E?
that's right.
Oh, okay. So I was trying to do the E and then add the other number. Okay,
And then once you have that,
then you
then
can
you
just
multiply by
multiply.
the 25,000, right?
Perfect. Thank you.
Right.
Okay.
Did you get it? So you start with the x first.
Yep,
So you're gonna start with this
yep.
before calling the exponential function.
Got it. Thank you.
No problem.
Okay. When I tried calculating the bottom and then dividing 25,000 divided by my answer, I got close, but it wasn't exact. It was 12,169.
Well, did you, maybe because, how did you do that?
Well, I just did 0.08
Yeah,
times 9
Uh-huh.
equals, and then I did the exponential.
Uh-huh.
So then I did 25,000 divided by that.
Yeah, because you rounded, that's why.
Well, I have 4 decimals.
Yeah, but still, it is rounded. You understand what I'm saying? Even if you use 10 decimals, it's still what? Rounded.
So that would be wrong.
Well, no, it would not really be wrong, but it's just that the reason why you have a different answer is because of rounding.
If so, if I showed that was how I did
Yeah,
it,
that's
it would
fine.
be okay.
That's fine, but I'll tell you how you could do this.
I know, I saw what you did. I
But even
calculated
the way
it
you
that
did it,
way.
I'll show you. You said you did what again?
I did 0.08 times
Nine.
9, and then I did the exponential,
Okay.
which is
Mhm.
there.
And then,
So then I did
What did you
25,000